Hi friends, my name is Nilesh. This video is the continuation of 15-factor app series. In the earlier videos, we have seen 4 different parts of this series and 8 different attributes out of the 15. So we have covered more than half of the attributes so far. Starting with part 1, where we talked about code bases, which talks about having one single code base which is tracked in the version control, which can be used to have multiple deployments in different environments. Then we talked about dependencies, which is essentially separating or explicitly declaring all the dependencies for a particular application and also isolating those dependencies. In part 2, we looked at config, which is about storing the configuration or environment specific configuration for an application external to the code, and then the backing services, which treats the external stores or services as attached resources, like the messaging services, databases, caching services, and so on and so forth. In part 3, we talked about the design, build, release, and run stage separation and having a clear demarcation between when a code is built and how it is deployed into the target environments. We also looked at stateless processes, which helps us to create standalone processes and make them scalable. In the last part, or the earlier video of this series, we talked about port binding, which is used to expose services via the port binding. And we also looked at the concurrency, which allows us to scale the application via the process model. In this particular video, we are going to look at the next 2 sets of attributes or next couple of attributes, starting with disposability, and then we look at dev and prod parity. So let's get started with the first attribute, which is disposability. What does disposability mean? It means that the processes that we run, our applications, they are disposable. They can be started and they can be stopped very easily at a moment's notice. If you look at the characteristics of cloud native applications, they are highly resilient and highly scalable applications. They are built in such a way that they can start very fast, and they can also be shut down very quickly. This helps in moving the application to different environments or different hosts in the cloud environment. So let's say something goes wrong with the underlying host where the application is running and the cloud provider has the high resiliency enabled. It can easily move the process to a different machine altogether, or a different VM, or a different service. If it's a PaaS service, it can start a new instance of the PaaS service. In such scenarios, the application has to be able to respond quickly when a new instance is spawned. If it takes a lot of time for the application to start up, it could pose a problem. There could be some default settings at the cloud provider level which might stop it from starting if it takes a long duration of time as part of the startup process. When we are using things like Docker containers or Kubernetes, there are concept build, or there are out of the box features which enable us to provide this highly scalable and resilient features. In the diagram above, I have shown a small snippet of the readiness and liveness probes which are used as part of Kubernetes manifest files. This allows us to specify when a particular pod or when an application is ready to accept new requests, and if it is already in the running state, then it can provide us a status saying that it is live and it is running. So these 2 probes, these are called as probes in the Kubernetes terms. The readiness probes allows us to express the desire of the application to say that it is ready to accept new request. And then liveness probes will tell the application or the orchestrator, Kubernetes in this case, that the application is live and the request can continue to come. There is also a startup probe, which can be used in scenarios where we need specifically some services or some preconditions to be satisfied before the application can be marked as ready to accept the request. So this allows us to have a maximum robustness in terms of the fast startup and graceful shutdown. Graceful shutdown means that if something goes wrong and the application has to be shut down, then it again is able to shut down itself very quickly in a graceful manner. And when this happens, the state of the application is maintained correctly. It doesn't cause any things like data corruption, or it doesn't leave the state hanging in between. if you are using things like messaging, for example, and if the process has to be restarted for some reason, in such cases, the acknowledgement that goes back to the RabbitMQ queue saying the message has been processed should not be acknowledged, for example. That's just one example that I'm giving. So we looked at various things here in terms of disposability and the fast startup and the quick shutdown or graceful shutdown. Let's move on to the next one, which is about the dev prod parity. In 12-factor apps, this was called as the dev prod parity. In the 15-factor app terminology, this is called as the environment parity. So before the cloud native applications became popular, mostly the development and deployments rather, was done in a semi-automated way or manual way, and we had different environments where we would test the code and promote the code from, let's say, dev stage to a QA to staging to pre-production and production. The idea of environment parity, or the principle this tries to promote, is across all these environments, we should try to keep things as similar as possible, which helps us to debug the situations. If in case there is an issue which happens, we should not be in a situation where, let's say, the operating system is different between the production environment and development environment, or the drivers that we are using, let's say, to connect to the database, they are different between different environments. So some of the factors which could cause these differences between the various environments, they include scaling and reliability needs. Say, for example, dev environment or QA environment, we don't really need to enable auto scaling, or there are not a huge number of users. But when it comes to production, we might have a different scaling needs and reliability needs. We might not have a highly available environment when it comes to dev, but production, obviously, depending on the criticality of the system, we might require to have different reliability needs in different environments. The other thing could be different database drivers. I've shown a small example here in the diagram above. So in the development environment, we might be having an embedded database like H2 database. When it goes to the staging environment, we might be using a Docker container and a containerized version of a Postgres database running as part of Docker container. When it reaches the production, we might be using a PaaS service like database as a service, and the icon that I've shown here is the Postgres database for Azure. In this case, the drivers which we require, or the abstraction which is required to connect to databases, is different between staging and production. It might be similar because we might be using a binary compatible version of Postgres, but H2, we would be managing the connections here using a different configuration setting. So if an issue happens, let's say in production environment, and we have to reproduce that, it could cause problems, or it could be challenging if it has something to do with the version of the driver. The other examples could be the security rules. They could be quite lax in terms of lower environments, whereas pre-production and production, we might have very strict security rules. Firewalls, again, similar configurations. It could be different in different environments. And this could cause, or this could pose problems when issues needs to be debugged and they need to be reproduced. And it hampers the ability of the developer to say that 100% what is tested on the developer laptop or in a lower environment works the same way in the higher environment if the configurations are different. So some of the common culprits when it comes to, again, this drift in the configuration between different environments could be time. So when the developer develops the code and when it is deployed to the target environment, that could be a difference in the time. Earlier, there were various handoffs which used to happen before CI/CD became quite popular. So we had teams like who were specialized in developing the application. Then there were teams who were specializing in building the application, and then there was the release management team. And at each of these stages, there used to be a handoff happening, and it made it difficult to reproduce the issues and to transfer that knowledge. Nowadays, with DevOps practices coming into picture and DevOps being adopted by many organizations, the team which is developing the application is working closely with the ops team, and this handoff has reduced. and because of that, we can see a reduction in the number of bugs which can arise due to the handoff. So try to reduce the time between which the application code is developed and it is deployed. Many of the organizations which are doing like hundreds of deploys a week or more than that, they rely on automation, and that is the next part where we talk about people and automating deployments using CI/CD pipelines. So as I said earlier, there could be different teams who are developing, deploying, and building the applications. By reducing the handoffs between them and by automating as much as possible, we reduce the lack of knowledge or loss of information between each team. And it might be difficult or it might be challenging to set up a CI/CD pipeline initially for the first stage or first environment. But once it is set up for, let's say, a dev environment, it becomes easier to replicate it for the QA, pre-production, and higher environments. So the automation helps us to reduce the errors which could happen due to manual deployments. And also when people move across the organizations, if there is only one or two people who know how to deploy the application and it is not documented, we lose that information, we lose that intellectual property. Whereas if we automate that process by using things like the pipelines and also storing that pipeline code in the source code system, then we are easily able to replicate that process across multiple environments and across multiple teams, and we can scale that process across the organization as well. The third thing is about the resources, where we talk about differences in the resources. So the example which I took earlier, the resources could be different between dev environment, staging, and production. If we are relying on modern day technologies like Kubernetes, Docker containers, or containers for that matter in general, they help us to make this very easy, because we can use same Docker container image and we can deploy it across the environment. So the concept which used to work earlier, or which was quite common, saying it works on developer machine or it works on my machine, it doesn't really apply, or it doesn't apply in the same way with the containerized applications. We can replicate our environment the same way across all the different deployments. And when it comes to the people, the other thing that I had in mind was about things like the different advanced techniques we can use for deployment. There are things nowadays which people follow, like blue-green deployment, where we have two different environments and they can be swapped easily when we want to move from one version to the other. There are also things like the canary deployment, which allows us to deploy to a small set of users and then progressively roll out the changes to more number of people based on automation. So we can have automated scripts which checks that the performance is fine. We can run automated tests like the functional test, the behavior test, the unit test, and once all these tests pass, we can roll out the changes to more number of users. There could be scenarios where a team is working with some other teams and their release cycles could be different. So team A could release first, but the feature that they are releasing is dependent on some feature which needs to be released by team B. In such cases, we can use things like the feature flags, where the code could still be deployed to the production, but it is not enabled or it is not activated. And we can use these flags, which are more like configurations, to enable and disable features as and when they are required. So using these kind of techniques, we can reduce the time which is required to deploy the application and when the change is done in the code side. So after completing these two factors or covering these two factors, here are some references that I would like to share with you. First one is the Beyond 12 Factor Apps, a book or a report from Kevin Hoffman, published in O'Reilly, from where I am referring most of the things that I explained as part of this 15 factor app series. There are also two GitHub repositories, one by Christopher Judd for the 15 factor app workshop that he conducted, and then there is a GitHub repo by Vikas Gupta. It is also related to a Medium post which he did. And then there is the 15 factor cloud native apps Java application, specifically by Grace Jensen from IBM. You will find the links to all these resources in the description of this video. So, in summary, what we have done so far, or what we have covered so far in the 5 different parts of this series is we looked at 10 different attributes and coverings from the code base, database dependencies, then config, backing services, moving on to design, build, release, and run separation, and the stateless processes. In the last video, we looked at port binding and concurrency. And in today's video, we looked at disposability, which allows us to maximize the robustness of our application with a fast startup and graceful shutdown. And also having the environment parity by keeping all our environments as close as possible to one another. So I hope you found this useful. In case you find this series and the other videos that I've published useful, please hit the like button. And if you would like to get more updates about the future videos, please subscribe to the channel. Thank you for watching this. Until next time, code with passion and strive for excellence.